Hello, everyone. Welcome to the after lunch session. We'll do jumping jacks like in the middle or something to wake all of you up. We are being live streamed apparently, so I need to remember to repeat any questions you have, so feel free to remind me that I need to do that. And hopefully the tech is working for them. So I did put on here, there's an extra credit opportunity in this class. It's not really class, is it? I always say class. You can actually download my code and put it into RStudio and walk through what we're doing. You'll have the data set and everything in there. So you could even do this afterwards, it'll still be available. But while we're going through this session, if you want to get out your laptop and start clicking around, you can. So first, a little bit about my company. I work for Red Pill Analytics. You can choose to see data differently is our slogan. You can follow us on Twitter, LinkedIn, YouTube, and Facebook. And one of our founders, Kevin McGinley, who you guys probably all know at this conference because he's a conference chair, he puts out the DataViz daily videos. They're almost daily. I think he does like 3 or 4 a week, getting into different like BI tools and different ways to play around with how you visualize data. So subscribe to that if you are interested. So here at Kscope, we are the analytics sponsor, I believe is our name. All we're offering is the truth, nothing more. So you'll see like little telephones throughout the venue. There's one on this floor, one on upstairs, and then one outside the exhibit hall. We're asking questions, and you can hit a button on the phone to vote. Then also on your name badges, there's like the little beacon behind your badge, right, that's tracking everything you're doing here. And we're doing analytics around that. So you can check out our dashboards on the screens outside the exhibit hall of what we're tracking.
How's it tracking?
So there's like a little device like in this room that is using beacon technology to track to that beacon on you. So they know how long you're sitting here in this session.
Cool.
I forget the vendor that actually provided that beacon technology, but yes, it's it's pretty interesting how they're tracking you walking around here. So yeah, stop by, talk to us, see what we've done. Our dashboard's in the Oracle Analytics Cloud if you're curious about seeing that tool also. So about me, I work for Red Pill, like I said. I used to work as basically a BI person. I was the manager of data and insights engineering at backcountry.com. And then I also worked at Intermountain Healthcare. I'm an Oracle ACE. I am the Executive Vice President of the IOUG, the Independent Oracle Users Group. We put on Collaborate, which you've probably heard of. The food is better than what they said in the keynote. If you don't get good food, come talk to me. I live in Utah, so I run the Utah Oracle Users Group, and I teach at University of Utah and Utah State, hence the extra credit opportunity that I'm giving you here to follow the code. All right, so first I wanted to ask all of you, do you have a data quality problem? Do any of you think you have a data quality problem? Only a few of you? Oh, come on. You're in denial. Gartner actually estimated that more than 25% of critical data within Fortune 1000 enterprises is flawed. So yes, there's a huge data quality problem that we have on our hands when we're trying to do analytics, when we're trying to use any type of data. When you lose trust in your data, your consumers of your data lose trust in the data, they're not going to use it. At Backcountry, there was like a manager who basically said, well, I looked at that dashboard 6 months ago and it wasn't right, so I won't look at it again. So you really want to make sure that everyone that's using your data, looking at your data, can trust it. That's where data profiling can come in. So when we're doing data profiling, we want to check for the accuracy of the data. So does the data say what you would expect? Expecting that sales was $100 yesterday, it should say 100 or be close to 100. Consistency. Are the same items always labeled the same? So if I show you an apple, am I always calling it an apple or not? Completeness. Is the data filled in where you'd expect it to be filled in? Are there nulls? Uniqueness is on identifier fields, are the values actually unique? For distribution, do you expect a bell curve? Is there a bell curve in that data? Is it showing what you would expect with how it's distributed? And range would be, are there values outside of the expected range? For instance, if we're looking at age, and you see someone with an age of 250, you would question that that's probably not right. So that's what we want to look for in our data before we start any project. This shouldn't be like halfway through your project, your data project, you start looking at your data and starting to learn about the data you're working with. This really should be at the front of every project, learning about the data set that you're being asked to analyze, to pull into your data warehouse, whatever you might be doing with it. So why are we doing data profiling? The benefits are you're going to gain that trust that I mentioned. You can find those problems in advance. So again, if you're doing this at the beginning of your project, then hopefully your project plan can change based on these problems you're seeing, and you're going to identify them up front instead of delivering something and then seeing the problem, having your users see the problem, and then needing to go like rework your code or whatever it might be. It will shorten your development time on projects, improve understanding of the data in general, and your business knowledge. I know at Backcountry, I knew so many of our systems better than like the source system engineers of those systems, because I was really digging into that data and getting to know it, whereas they knew at a high level, well, that field's supposed to store this. No, it's not actually storing what you think it is. It's adding all these other things, and that's what I learned through data profiling. So what should you be profiling? Profile anything. Just any project that you're working on that has data, you should be learning about that data before you use it. So why use R? I know one of you asked, well, why isn't this R for Python? Well, it could be. I'm really interested in R in general. I teach it a lot at University of Utah. A lot of students want to learn it. I think it's a really powerful tool. And what I think is most appealing to this type of audience is not all of us are like statisticians, right? We maybe don't feel that comfortable in R in general. Or maybe you haven't used it at all because you think, well, it's a statistician's tool. So getting into R in this type of session is my approach to show you, hey, R's not that scary. It's not for people that only know how to do like logical regressions or even know what a logical regression is. I want to show you that R is something that you can use in your everyday job that isn't as intimidating as it looks, and yet then you can impress people like, oh yeah, I use R. Like, you can start talking to those statisticians like you almost know what they're doing in their jobs. I also like R because it's free. It actually is pretty easy to use. Yes, it's a programming language, but it's pretty flexible. Is there an echo? Am I hearing an echo? Okay, I'll just ignore that. It's really powerful for analytics and, like I said, for stats purposes, but there's a lot of packages that are being built in it that are really flexible you can use for different purposes. Like my session today, I'm really not showing you how to do stats and how to do like analytics. I'm just trying to show you, here's how you can learn more about your data using R. And then there's this great community because it's open source. There's a lot online about here's how you use this package, here's what I used for this, and competitions that you can learn from what others have done in R. So you really can learn a lot about R just through the community. You don't need like formal training in R. So getting started in R. I mentioned that it's a programming environment. But those of you that might not be programmers, don't worry. It's not going to be too intimidating. It's fairly simple to use. It allows you to manipulate and analyze the data. But the real power comes from everyone who's adding packages to the community. So again, it's open source, so people are adding new packages like every day. I basically follow all these blogs to like learn about the new things coming out every week just to keep up. Because there's always seems to be like a new package that I want to try and play with. Now the one I guess it's two that I list here. Memory management and speed versus C++ and Python is bad in R. So R, if you're doing the version that I show in this presentation where we're just using RStudio, I'm running things here on my Mac. So I'm limited to the resources here on my Mac. It loads the data from a database or wherever you try to load from into the RStudio environment, so it's running just on your own computer inside that memory. So it can be slower. If you are starting to do more complex things within R, I would recommend like using Oracle R Enterprise, something where it like pushes the R coding to the database and uses your database resources to run it instead of your own computer. So for R, I mentioned that we use RStudio. So the first thing you want to do is download R from rproject.org. Then use RStudio as my recommendation. I think it's the best IDE for working with R, but it's not required that you have to use an IDE. I will be showing you RStudio here. So some basics just to get us all on the same page. R is case sensitive. To assign a variable, you use the caret and a dash. A comment is a pound sign. And if you're ever trying to find some help on what you're doing, just do question mark, and a keyword. And it's going to search the R documentation for you. I mentioned that there's packages in R. So a package is like a set of code with functions that you can leverage. To use a package, you need to install it. So we install it saying install that packages and the package name. Once you've installed it into your environment, every time you load up your environment, you need to reinitialize that package or load it in. So to do that, we use library. So that would be like every morning you're going to have to say library and then the package you're using. But you wouldn't need to install it again. Within RStudio, it does show you over here on the left the packages that you've installed, and then the check marks are the ones that you've loaded into your environment. So RStudio makes it really easy to see what you've been using so far. I will note also it shows you the version of the last update that you put onto your computer. If you do need a new version of a package, you just install it again. So you would do that install that packages and it puts the latest version on for you. To connect to data, I find that it's easiest to pull in from CSV. The code for doing that, it can download from a website, or you could just connect it to a file on your own computer. You say read.csv and then you give it the path. So here I gave it a path to a URL. And I assigned this to a variable in my environment. So I called the variable D, and it's going to load that whole HSV2 CSV file from the UCLA website into my own environment. So it's loading all of that into my RStudio environment. Because this is an Oracle conference, I will talk about how you can connect to Oracle. You can use RODBC. I found this to be the easiest to set up, but it's not the fastest. So you use a package called RODBC. You can look at your data sources available. You can set up a connection with your connection information, and then at the very bottom there I show how you can pass a query to collect the data that you want and store that again into a variable in your RStudio environment. So that RODBC is just pulling data from your Oracle database into your RStudio environment. So it's not running it within Oracle.
Sorry, the SQL query that you run, that is running in Oracle.
That does run against Oracle. Oh, I need to repeat the question.
Sorry.
The SQL query that you run is running in Oracle, but it's just extracting the data using that query. And then every time you do things further on in your code against that data set, it's running it within your own computer.
Is there a way in the RODBC library to push it back into Oracle?
So the question was, is there a way from the RODBC library to push it back into Oracle? Yes. I don't remember offhand exactly what the code is to do it, but yes, you can. So another method of connecting is JDBC. So this one is called RJDBC. You create your connection driver, you open your connection, and again, you pass it a query. With this one, you have to also close your connection when you're done. But the big one that I think Oracle wants you to use, and that they seem to be promoting more because it's faster, is Oracle, I'm putting R in front of Oracle, sorry. Oracle R Enterprise. This one is open source, but it's maintained by Oracle. They say it's 79 times faster. I haven't seen that kind of speed, but I'm never in the perfect environment that they're using. It supposedly will provide scalability and stability, so it's worth it to go through it. But I will tell you, this took me about 6 hours on a Saturday one day to set up, so I didn't feel like it was the easiest thing to set up. That ODBC was really helpful for me when I just wanted to quickly connect to a data set and start really doing things in R. I didn't really care about the setup in Oracle and that taking so long. So if this were an enterprise environment where I really am trying to do things that will be using a lot and connecting to the Oracle database a lot, I recommend considering the Oracle R Enterprise. But if you're just like rogue playing with this someday, I would just use RODBC or CSV to get the data into your RStudio. Oh, and I put the Star Trek thing on there because that's like my one picture to relate to all the techies. And I was told like I need like geek stuff in my slides. So Enterprise reminded me of like some Star Trek thing. I'm not a geek enough for some of these presentations. Oh, it's Trekkie, not techie. Sorry. See, I'm still learning. Don't tell my bosses I haven't even seen Matrix yet. Wait, is that recorded? They know it, they know it. We're going to have a movie night sometime. Okay, I digress. Last thing I wanted to tell you about R, we use variables. And I've mentioned variables. So variables are things that you're storing a data set in. You might just be storing one value in, but you can leverage variables throughout your code. To write to them, you either use that -- or the equals. You do not need to define the variable first, for those of you that are used to that in other languages. And RStudio will display all the variables that you've defined and any values that have been set in them for you. So let's get into RStudio. So this is how RStudio looks, not right when you open it, because I did some things in here so it doesn't look all white and boring, but this is the basic screen. So there's 4 quadrants that you work with within RStudio. So first I'm going to go up here to the top left. This is where you're writing your code. This is basically where I spend most of my time. I usually make that window a little bit bigger. It doesn't have to stay so small. But this is where it's going to allow you to actually save what you're doing. So my students make a mistake of adding code in another spot that I'll tell you about, but then you can't save from there, and then the dog ate my homework excuse comes out. So try to stay up in this top left corner. That's the best spot for you. Then moving out, here at the bottom here, this is showing the lines of code that I've run and any output from them. So you can see here that I loaded the library ggplot, and it gave me a little bit of output about it. This is where you could type a line of code and run it, but it's not going to save that. You would be able to maybe get it from your history in RStudio, but it's not ideal. So use this more as your output section to see what you've run. Then let's go back up to the top right. In this section, we have our environment. So there's this handy little button here for import dataset. I showed you how to type that read.csv within R. RStudio gives you this nice little GUI that you can just click import dataset, and you could point it to that CSV file, and it'll load it into a variable. Then also, it's showing us the variables that we've defined. Here you can see that my mobile data variable, we have 1900 observations, and there's 3 fields in it: date, mobile operating system, and % of usage. So it shows you some information about those fields and the data that you've loaded into those variables. Then the history button, this shows you the history of all of the lines of code that you've run. I'm going to pan out for a second and show you there's this one little button at the very right there for each of your variables. You can see that it looks like a table. If you click on that table, it's going to open up in the top left a preview of that data frame for you. So you're able to look at your data sets easily. Okay, then the bottom right, this section shows you your plots. So these are like graphs that we've done. You can see here I did like a very pretty bar chart for you. Oh, I should note there too, there is an export button that you could export this to JPEG, to PDF, and share with someone if they don't have RStudio. There's help, and the help is actually really helpful. It's a great open source community, as I mentioned. So you can search for things under that tab. Here's that packages tab that I mentioned earlier. And then we're back to plots. So that's RStudio. So now let's get into actually profiling data. So we're going to use NFL data. And this is me being not trying to relate to my audience. I actually am a huge NFL football fan, and I like the Green Bay Packers. And so we will talk about how Aaron Rodgers is the best quarterback. So if any of you want to leave now and don't want to hear it, I understand. But the data will show it's true. Okay, so the data we're looking at, it's offensive player stats and personal information from 1999 to 2013. So the first thing I'm going to do is load this data set in. I'm reading from a path on my computer. It was in my downloads, nfl.csv. If you're looking at my code on GitHub, you're going to see that it's pointed to a website of where this data actually exists. So that's the one line of code that's not going to be the same in GitHub. So the next thing I do once I load it in, I wanted to view it. So I use the function view, and then I give it that data frame name, which was NFL is what I chose to name it. That pulls up a view of the data set. We can see at the bottom here we have 8,100, 8,200 entries, so rows of data, and there's actually a lot of columns in here. If I look at the right side of our studio where it tells me about my data frame, I can see that it's listing like year, and it shows a bunch of the different years it's finding in the data set. The players, it's listing as a factor with 2302 levels. So our studio thinks of a factor almost like those of us in BI think of as a dimension, like something that has a finite number of instances in it, not many like unique values within it. But then it lists out the rest of the fields. So that doesn't really tell me much about my data. So this is where I really need to start profiling. So the first thing I'm going to do is a summary. So a summary in R is basically giving you some basic details about each of the columns within your data set. So to call that, I just call summary NFL, and then it gives me this output down here. And it's arranged by column here. So the year column, I can see the minimum value was 1999. The max was 2013. That's exactly what I told you it would be. Let's see, let's look at a more interesting one. For age. Age, I have a minimum value of 21, a maximum of 44. I mentioned that range is something that's important when you're data profiling. You want to see if it's in the range you would expect. I might question if we really have a football player who's 44 and still playing, but it could be possible. So I think that our data set's probably clean in that age column. So I would just start looking through all of these columns, and the output continues on. There's a lot of fields in this data set, so I would probably go through more effort if I were really data profiling this at this time. But I'm going to skip ahead. The next thing I wanted to show you is that we can filter our data set. So because we have so many years of data, I want to filter this down to just 2012. So to do that, I use the subset function. So I subset the NFL data set where the year equals 2012. And you can see for comparison, I use equals equals. Then I did the summary on that. So another thing to note here is you can nest functions, like you can in other languages, like SQL. Now that I'm looking at just 2012, I would expect year to only have 2012, and it does. But I can see that we have Alex Smith listed twice and Steve Smith listed twice. That's actually because they're two different people with the same name. One thing I don't like about this data set, well, this data set's very messy, so there's a lot of things I don't like. But one thing is, there's no unique identifier besides name, but we can see that name is duplicated. So you could maybe find a way to make it unique by using the team and hope that they're not playing on the same team and they didn't have the same draft year and the college team, but there's not a clean way here for it to be unique. So that's something I note as I'm looking through this data. Now, the next thing I looked at was in the weight. I can see that the minimum weight was 0 and the max was 325. That max is probably correct, because let's be honest, they're football players. But the minimum, pretty sure that's wrong. So I might start to look into some of those things. And usually I just have a notepad next to me, or I really like Post-it notes. So I'm probably writing on my Post-it notes. I probably want to look into weight and look into this one. And then I'm jotting down all these notes of these data points that I think I should investigate more. So when I think I see bad data, like in the yards, I see that our max is 5177, but the mean is only 218. So I'm thinking, well, is that max correct? Or is that a typo that someone really got that many yards? So to look into that one, oh, that was my football player animation, you guys. You want to see that again? Let's do that again. Ready? Boom. Okay. All right, so aside from the football player animations, which are fun, what I did here was I decided to filter down that data set to just the record that had the yards of 5177. So here you can see subset 5177. I found that that is Drew Brees. So Drew Brees, and I looked this up on the internet, actually did have 5177 passing yards that year. So he had a lot of yards, and the reason why the mean was so small was because there were actually a lot of like second string quarterbacks that really didn't have many yards, and they really brought down that average. There really were only like, I think maybe 20 quarterbacks or less that had yards over 4,000. So our data set for yards as we're looking at it here appears to be correct. But then I decided I want to group this by position. So to do a group by, those of us that know SQL and think a group by, it's just called by within R. So here I'm using by, and then I told it I only want these 4 columns. So to do that, in the brackets, I put the comma C, which stands for column, and then I give it the name of those 4 columns that I wanted. And then I want it to group by the NFL 2012, that's the data set. Then I use a $sign. Think of that like in SQL where we use the decimal to like say table.column. In R, it's like I'm saying variable or data frame dot fantasy position is my column. So it's kind of similar notation, just a little different. So I'm grouping it by position, and then I want it to give me the mean for each of those metrics by column. So the results that I get here are quarterback, their average age is 27, their yards, 1745, but then here I see the weight of 0. So here's where I realized quarterbacks actually don't have to report their weight. Surprise, surprise. I'm not sure why, but this data set was missing that. For running backs, I noticed that we have no yards for running backs, and running backs, running with the football, they should have yards, right? This was something I decided to look into, and that actually was stored in another field. So we had 2 columns that stored yards, because that wasn't easy enough to only put it in 1 column, apparently. Tight ends and wide receivers had yards, but they were pretty small. But their weights and heights all looked about what I would expect. So now that we have kind of looked at some of the basics of the data, let's start visualizing it. Because when we visualize data, things might be pulled out that draw our attention better than what looking at like a spreadsheet of data might do. So in R for visualizing data, the package that I like the most and what a lot of people use, it's called ggplot. And it stands for Grammar of Graphics. This was a book written by Leland Wilkinson. I think this was like back in the 70s or a long time ago. But it had some good principles about how you visualize and display data. So we're going to use a package that was not built by Leland. I forget who this package was built by. But the book inspired the code for Grammar of Graphics. So to install this package, I say install package ggplot2, and then I load it into my environment. So the first thing I want to do is do a bar chart. And I decide I want to look at the distribution of age and just see, like, do we have what we would expect for football players' ages distributed? Because football players are typically within a pretty small age range, and I would expect there to be like a spike probably near the beginning, because football players' careers can be rather short at times. So the code for doing this, I used qplot function. I want to plot the age. I'm using the dataset NFL 2012. The geom that I'm doing here is bar. And then main, this is the title. That's the title of what I want this bar chart to display. So when that comes in, we can see the distribution here of our ages. And it looks like around age like 24 is when they're spiking. And I think that's probably about right, that our football players are typically mostly in the younger range. So the next thing I was looking at was that I really would like to see this as a histogram. Because a histogram is better for when we have like discrete data, not continuous. Or sorry, did I just reverse that? When we have, no, yeah. Yes, histogram is better when it's continuous, not discrete. But what R thought that I did here, when it imported the data set in, it tries to assume those data values, what kind of, gosh, I'm forgetting all my terms here, what kind of data it is. So it like assumed that year is an integer, the Wonderlic is a factor, etc. So when it pulled in age, it thought that it was a factor. Or sorry, the yards was a factor. So what I did is, there's a few ways that you can like get around this, but the easiest way that I found is to change my data set to a matrix and then change it back to a data frame. And I haven't really talked about what a data frame is, but a data frame is like your generic, think of it like a table in the Oracle database. It's very structured the same. So by moving to a matrix and then back to a data frame, I was able to get it to realize that like our yards are numbers instead of factors now.
So what's the distinct difference between the matrix and the data frame?
What was that?
What is the distinct difference between a matrix and a data frame?
So the question is, what is the distinct difference between a matrix and a data frame? So I don't use matrices very often. I've only used them once in like a real case, but it has more dimensions to it. So you could think of that as more of like a 3D type of structure versus a table being 2D. That would be the difference. So I haven't come across many data sets in R where I've needed to actually use a matrix.
Is there a reason though why you can get the numeric like conversion functionality out of it?
I don't know why this hack works. I just happened to be playing and it worked.
Oh, okay.
And so that's what I do. That's why I say there's actually like more formal ways that you can change these. But the more formal way is like you have to do column by column.
Yeah,
and because I had so many columns, then when this worked, I was like, well, this works.
It's really cool.
I'm going to make sure that's on here. He said that's really cool. In case this is being recorded. All right. So now that I have everything as numbers, I can actually graph this 40-yard dash number as a histogram. So to plot that, I did ggplot function. I'm doing it on my modified data set that I just created that you saw. I want my values that I'm plotting to be the 40-yard dash, so that's going to go on the x-axis. And I want this to be the geom of histogram with a bin width of 1, which basically means each bar is just going to be one data point. Like, so 25 has a bar, 26 has a bar. So once I see that we have a data problem here. We have 170 values here that are in this 1 or 0 column that's really skewing the rest of the chart, and it makes the rest of those data values pretty small that I can't read them. So I thought, well, what if I change my bin width? So I'm using the same code there, but I changed bin width here at the end and made them a little blockier. That helped, but it's still not ideal. So I needed to filter out those 0 values. So I did that by creating a new variable that I called no 0 and 40, and I did a subset where the yards are greater than 0. But then once I plotted it using that same code that I had before, just changing the data set that I'm pulling from, it actually didn't change. So that's when I realized, oh, those values were all a 1. They weren't even 0. So good thing I learned about this, because if I would do like an average on the yards and I had all these values with 1, it would really skew that data set, right? So once I got rid of the 1s and did the 40-yard dash greater than 1, now we can see a better distribution here of our histogram. So then I decided to do a density chart. And I like density charts, and other people like density charts also, because compared to histograms, because you don't need to worry about those bins. You know how I was playing with the bin width of 1 versus 3 and how it changed the chart? Maybe that's just too complicated. You don't want to deal with that. You can use a density chart where it shows it as a line graph, and it kind of curves it and makes it look prettier as a distribution. To do that, I used ggplot again. Basically, the only thing I changed was down here at the end. I said geom density instead of geom histogram. And then I got this nice chart. And I do want to note to you that if I pull this in with my first data set that had the ones, all the values of ones, it kind of distorts it a little bit where I might think that there's values going from 1 all the way to, like, let's say 10 here, when there really weren't. If you remember back to the actual histogram, actually I could go back to that for you, it really didn't spike up until like value, let's say 15. So it's a little deceiving how it curves that, and that would be something to keep in mind. So if I were doing data profiling, I would use the density chart more to like see, do I have the spike where I would hope the spike would be? But I wouldn't use it for like exact purposes to say like, oh, I know that our data is distributed evenly between 0 and 15. So now that I've used that data set how I needed, I'm going to clean it up. So in R, to remove any variables and clean up your environment, you use the function rm, and then you give it the variable that you're trying to remove, and it deletes it. Next, I wanted to show you group by using visualizations. So we talked about the by function that showed it as just text. If we use ggplot, still the ggplot functions to do density charts, but now I add to it facet wrap of the fantasy position, we now see 4 charts for the 4 positions. Now one thing I will note, when I changed from a data frame to a matrix back to a data frame, for some reason my positions lost their names and they turned to 1, 2, 3, and 4. So that's a downside of playing with the matrices. I could add that back in, but I didn't in this case, just to show you what happens when you use that. So use that matrix trick with caution, or just do the actual method of changing your data values. So this basically, my point to show you this was to show that how, depending on what position they are, there's different ways that the data was distributed. So if we look at down here in our, I forget what one this was, I think this was the tight ends. The tight ends had like a lot of spikes here at the bottom of our distribution, showing that there's probably a lot of tight ends that didn't actually run the 40-yard dash, or their data didn't get tracked. Now, when we talk about categorical data, like position, we might want to even just look at how many rows fall into each of those buckets that we're expecting. One way that you can do that is with the X tabs. So here I did X tabs of the position with my NFL data set, and I can see that we have 72 quarterbacks, 176 wide receivers, etc. So that would be one way to see, like, is it, again, distributed how I would expect. Then I pulled up the draft year, and I looked at counts. And we can see a wide range here, but what was really disturbing to me about this part was the draft year of 0 had 200 records. So again, we have some bad data in here in that a bunch of players weren't drafted, which is okay that they're not drafted. We know that happens in the NFL, but instead of maybe putting a null in here, they're putting a 0. So that's just something that I'm noting as I'm profiling this data, because again, if I start to do like analytics on this, this could really skew the data I'm showing. So I want to maybe change that to nulls or find a way to handle for that. You can also do the X tabs for 2 data points. So to do that, I just added a plus sign between fantasy position, and I added draft year to this data set. So now we can see year across the top and position going down. Nothing too alarming in that data that we haven't already called out. So next I did a box plot. And this code in R is going to start to look pretty familiar to you guys as I show more and more of these. It starts out the same, ggplot, NFL 2012 data set. On the x-axis, I want the fantasy position. On the y, I'm plotting height this time. And I want it to be the geom of Boxplot. So it gives me this Boxplot. And what Boxplot, again, shows you is like distribution within there. So you're seeing like your quartiles within that data set. and we can see that the height of the players is a pretty small distribution in general, except for this one little wide receiver. That was the best picture I could find of a short football player. They're actually not that short. But I would guess that this is probably bad data, because that value was like 5. And I don't think someone's actually 5 inches and playing in the NFL. So that would be a data point that I would consider an outlier that I would maybe exclude from an analysis or try to like clean up if I could find the right value for that. Another visualization I wanted to show you was a scatterplot. So scatterplot could show 2 different metrics, one on the x-axis, one on the y, and show you how your data falls within those 2 once you're plotting out those 2 variables. So to do that one, I decided I'm just going to look at quarterbacks now. So I created a new data variable, data frame, just with quarterbacks, and I plotted this quarterbacks with the x-axis of touchdowns, y of interceptions. I decided to add color in here. There's actually a lot of customizations I haven't been showing you in everything I've shown so far because I'm trying to keep it pretty basic. But I do want you to know there's actually a lot of cool things you can do within R to make your visualizations pretty, make them meaningful. For the purposes of data profiling, you probably don't need to like make them too fancy, but I wanted to let you know you can. So here I did coloring by the year, and then I used geopoint, which is how I got Scatterplot, and then I can specify what kind of shape I want. That's optional also, but I decided to do a shape of 1, which is the circles. We'll see another shape in a minute. And then after I ran this, I removed my quarterbacks variable just so I could clean it up. So here you can see the distribution of interceptions to touchdowns. We can see that in general, like there's probably a line we could draw in here of where they mostly fall of how many interceptions they'll have based on how many touchdowns. But we do say there are some quarterbacks who have been pretty effective. The ones up here are not as effective, but the ones down over here at the right have had a lot of touchdowns and not very many interceptions. So probably all Aaron Rodgers, of course, right? Entertain me, come on, say yes. Okay, so then I know I told you like we won't really talk about stats in this session, but I did want to show you how easy it is to add regression if you understand what regression is and what we're trying to do with regression. I would caution you, don't just add a regression line to every chart because you're trying to look smart for your boss, because then they're going to ask what it means and you have to actually explain it. But how you would add it is at the end of that code that I just showed you on the last slide, I added geom smooth, and the method is an LM for linear model. That added this blue line, and then it shows a gray bar with my confidence interval, which is pretty slim on here. So hopefully you're starting to see within R, you can use these plus signs to just kind of keep adding to your chart, add more variables, whatever it might be that you're trying to do. Use these plus signs to keep adding on and adding more value to what you're showing. Next, let's show a line chart, because everyone uses line charts, right? So here's what we're really going to compare quarterbacks. So I decided to look at just 3 quarterbacks: Aaron Rodgers, Peyton Manning, and Tom Brady. Editor's note, I excluded Drew Brees because you already saw how many yards he had and he just skewed all the charts. So let's leave him out. So now I'm going to do, again, a ggplot of the quarterbacks. I'm this time mapping out the year by completions. I'm going to group it by players, and I want to color it by players, and then I'm displaying it as a line chart. So that gives me this chart, where again we can see like the 3 players listed here over in my legend, and it gave each player a different color. We have year at the bottom and completions on the left. So now I'm seeing like, sure, Aaron Rodgers might not have had a lot of completions, okay, but he was still effective. Bear with me here. And there were some injuries in there, right, too? Okay, so I decided to add a bar chart to it, and it did it as a stacked bar. But to add that, if we look at this top line, we see where I basically created the geom bar, and then I got into the line. So we're going to go from basically the first line. That didn't cut off very cleanly. But the first part of it I say ggplot, the data is my quarterbacks. I want to plot year, touchdowns, and fill. Fill is something used for bar charts. Fill by players. And that's going to be displayed as a geom bar with the stat of identity, which is basically getting the stacked. So that's how I got this bottom part down here. Then I add on to that, I say plus geom line, and similar to over here with the ggplot, what you've seen on other ones, I'm again pulling the data set. I tell it I want the lines to be year, completion, player, group by player. That's exactly the same as the last slide I showed you. Then the last thing I do is I want to change the Y label to touchdowns plus completions. That's just this right here on the left, on that axis. The reason why I changed that is because by default R will take your first value. So it would have only said touchdowns because that was the first Y that I was using. But I wanted it to actually say touchdowns plus completions. So that's how I got this chart with lines and bars. But I'm not a huge fan of stacked bar charts in many cases. So I wanted to put those bars next to each other so I can better compare because, like, let's look at year 2010. It's really hard to see which player had the most touchdowns there. It looks pretty close from how those colors are playing out as a stacked bar. So to split those out, we're going to look right up here at geom bar, stat equals identity, position equals dodge. So that's how I got them to be next to each other. The rest of that code on there is all the same, and how that changed is down here. You can see them next to each other. I probably would need to like blow this up better so you could really compare, but hopefully you can see that these three bars are different, and we can see like Tom Brady had the most touchdowns here. Now, my point that I want you to get out of this, who cares about the R code? Aaron Rodgers had less attempts or completions, but more touchdowns. So he doesn't need to complete those passes as much. He still gets touchdowns, people. Okay, that's the only point you need to get out of the session, right? Just kidding. R is fun too. Okay, so next I want to talk about text fields. So we've talked about a lot of numbers and ways that you look at your numbers to see if the data is accurate and what you would trust and want to use. For text fields, it's a little bit harder, but one thing that you could do is use a word cloud. So word clouds are really easy to create within R, and I'm going to show you a really basic one. Again, it can be customized and made cool. I installed the text miner package and the word cloud package, loaded those in, then I just said word cloud of the NFL college field. So this is the college that all the NFL players came from. It told me that Florida's too big. Basically, there's too many players coming from Florida. A workaround to that is make my plot bigger, basically. But here is the word cloud that it came up with. I would probably look through this and make sure that, are these all colleges? Do we have like misspellings in here? Are there things that I might be drawn to? Maybe I see Michigan and I think, well, does Michigan even have a good football team? Would they have that many players that come from it? And so that's some of what you could validate from a data profiling perspective, but text is definitely harder to data profile. Yeah, question. Sorry, what was that?
Install packages TM. What does TM stand for?
TM stands for text miner. Yep, and there's a lot of other functions within that text miner. I was just showing one, but word cloud uses text miner to build that word cloud. Okay, next I wanted to talk about missing data. Within our data sets, of course, it's important to have that completeness that I mentioned and make sure we don't have much data missing. But the first thing I want to call out is within R, compared to like SQL, where you guys are used to having nulls and you understand what a null is different in R. You actually don't see nulls that often. Nulls are a null object and a reserved word, but they don't even exist in some of the different in data types that we have. Instead, you'll see NA used more often, and it's basically a constant of length 1 indicating that the value is missing. So think of that more like null than what the null is. More like the null in SQL, I should say. So in our data set, I know that we had some nulls, that there were some fields that some players didn't have values for. And I can show you in like Jeff Garcia's record, in the CSV, we had right there a comma, comma. So there was no value listed. So I wanted to see how did that import in when I imported this in using that read.csv. Here's that same data set of Jeff Garcia's. And I can see that the yards receiving was NA. So it did pull in as the NA, not the null within R, and it came in how I would expect it to. So we can actually count these NA values within our data set. To do that, I used the sapply function, which has a lot of value within R. I don't really have time, especially because we started late, to go through what sapply does. But basically what I wanted to show is I'm using this sum of the isNA function to count how many NAs I have within my data set. Then I had to add the row headers back onto my data set, and then I view it. So the result is here it's showing me like yards attempted. We had 3986 records that were missing values within that. So again, with data profiling, I'd want to see, is that what I would expect? Would I expect more values for yards attempted? Why is that data missing, perhaps? So then I started looking at Jeff's records some more, and I saw all of these £n/a. And that was my face. Oh my gosh. How this imported in was really as a string, because R didn't recognize £n/a to really be a null. So when I counted his null values within his records, I substituted, that's what I did, and then I counted. So what I did here was substitute the £n/a to the NA keyword within R. Then when I count them, now I'm seeing 11 values, or 11 records that had those nulls. Whereas before I changed them around, I wouldn't have seen any. It would have showed 0. So this is another reason why data profiling is good, learning about your data, learning when you have these bad values that might skew your results. When I do this, the whole data set and check it, I can see we actually have a lot of nulls for like the Wonderlic and the 40-yard dash, and that's something I might need to figure out how I want to handle for that. So what do we do about this missing and bad data? Sorry, I'm going to go kind of quickly through these since we're running out of time. Statisticians basically bucket missing data into 3 different buckets. You can have missing completely at random, so it's not related to another variable why it's missing. For instance, like I told you quarterbacks always had weight missing. Well, that's not completely at random. That one actually fits into our middle bucket. It's related to another observed variable, but not to its own unobserved variable. So that's called missing at random compared to missing completely at random. And then not missing at random is basically not in any of those categories. So if we're in those first 2, it's the easiest to handle for. Basically, we ignore whatever is producing that missing data. We might try to replace it or delete that data before it. For instance, if we know that quarterbacks always have 0 for their weight, then if we were doing an average of weight, we would exclude quarterbacks maybe, or find another way to handle for quarterbacks. So, how do we handle for bad data in maybe our ETL or when we're loading data? One object is reject it. If any field in there is bad or something's bad, reject it. Another option is try to clean it. For instance, at Backcountry, when I was looking at our US states listed in our customer database, there were 252 different unique US states. One was actually God Bless America with a smiley face. So I could use the zip code to replace those states and come up with correct data. So find a way maybe to clean that up and make it useful. Because if I were to show that to like our executives, here's all the states that we're sending our packages to, they're not going to ever trust me. Another option is load it as is. You might do this if you're really trying to like push to get the data cleaned up by other people or make it more apparent that there are data quality problems. Okay, so lastly, is there an easy button? So we have this data quality package that we could use that does a lot of this, and I purposely saved this for the end because I want you to learn how to do all the hard stuff before I show you the easy part. The data quality package is just called Data Quality R. you say check data quality, you give it your data set, and then you give it where you want it to save your files. So it's going to give two output files, one for your numerical fields and one for your categorical. You save those two, and then it gives you basically a spreadsheet of results. So here's my numerical fields. It tells me how many are missing values, what the percentage of missing are, how many unique values, the min, mean, and then your percentiles. So it doesn't tell you everything I showed you before. You don't see outliers perhaps in here, but it gives you some of that information. For categorical, it gives you a lot of those same things, but it is summing up like Steve Smith, it saw 18 times, Alex Smith 17 times, so it's trying to sum up the values that it's seeing within it. So, in summary, R is actually really easy to use. You can play around in it. You're not going to break anything. I would really recommend playing with it if you have any kind of interest. Install it. Go through the code that I've given you. Learning about your data before you go into an ETL project, before you start doing analysis on any data, using it in any way is beneficial. And open source means you're not needing to convince your boss that you need these expensive tools that you're not even sure how you'll use yet. So that gives you a chance also to play with it. So, any questions?
I have a question from online.
Oh, question from online.
So you don't have to repeat my question.
Oh, okay.
Yeah, otherwise I tell you and just repeat yourself.
All right, I got a question. Will the word cloud work with sentences with many words, or do you need to separate them first in kind of map-reduce way, for example? So I actually haven't tried that, but I think it will work, because in the college's data that I showed you, for example, like Notre Dame, you might have seen, if I go even back to this slide, maybe it's too many slides ago, but Notre Dame was actually split out twice in my word cloud. Oh, did I skip it? Okay, wherever it was. It's in there somewhere. But it did split out those two. And so I'm pretty sure that if you had full sentences, it would, but I haven't used that enough yet to really know for sure. Was that the only question online? Perfect. Any questions from this room? Online people, they're not all asleep, but they have no questions. Okay, well, my contact info is at the very end down here. Oh, I just saw the word cloud too. Maybe it's not going to let me click. Just kidding, we're getting. Oh, and this session was recorded. Bosses, I love you. Okay, well, fill out your session surveys. My email's there. You can follow me on Twitter if you have questions too. Feel free to download the code from GitHub so that you can walk through everything I showed also. Yeah, and enjoy your conference.